Okay guys, we're talking about the accessory organs and the overview of digestion this time. So for accessory organs, I want to talk about the teeth first. We look at the teeth, we look at a general picture of the teeth. There are different parts you need to know. So this top part right here is the crown. So that's just going to be that top area of it where it's above the gums. Then you have under the gum, which is the root. All right, and now this root is embedded in the bone. All right, down the bottom. When we look at the tooth, there's different parts of the actual tooth. The enamel, which is in here, this section is going to be the hard part of the outside of the tooth. Then you have the dentin, which is the soft part. This is that area that you don't want the cavities to go into, this dentin area right here. That's once they start filling them, once they get through the enamels to the dentin. You have the pulp chamber, which is this middle area where you have all your nerves and blood vessels and all of your stuff that keep your tooth actually alive. So those are your teeth. Next, we're going to look at the salivary glands. When we talk about the salivary glands, there's a couple of different types. You have a sublingual, submandibular, and a parotid. This number one, that's your parotid. All right, it's the big one in the back. Okay, and this is going to release saliva into the back of your mouth. Then you have your sublingual and submandibular. These are these bottom ones. Okay, and those are going to release saliva into underneath your tongue. When we talk about saliva, saliva is going to be made up of 99% water, so it's mostly water. The other 1% is made up of other random things. These are going to be bicarbonate salts. Salivary amylase, now it ends in ASE, so it's an enzyme. Salivary amylase is going to break down carbs. All right, so that's going to digest carbs, our salivary amylase. You have lysozymes and antibodies, which are going to break things down and help prevent against bacteria getting in. Then you have mucus, which makes everything all slip-slidey so that when you swallow, it works all right. After the salivary glands, our next accessory organ would be our pancreas. Now keep in mind, these accessory organs are organs that are not part of the GI tract, so they add stuff to them. So the pancreas tucks in here in that inlet curve of the duodenum, and keep in mind that the stomach is right here. The stomach opens up here, right? The pancreas is kind of underneath the stomach, and the gallbladder is there, and that's on the other side of your liver, which is like giant over here, right? So your pancreas is going to produce a whole bunch of enzymes, and these enzymes break down food in all categories. So it's going to break down carbs, lipids, and proteins. The enzymes from the pancreas are going to be released right here into the hepatopancreatic ampulla, which is going to dump it into the duodenum. So the secretions from the pancreas will end up in the duodenum. And two of the big things that your pancreas is going to secrete, or these are help make your body function okay, are glucagon and insulin. This is for the endocrine function of your pancreas. So this is the things that are secreted right into your bloodstream. The insulin and glucagon help manage your sugar levels. Right, the rest of the stuff that the pancreas secretes are just called pancreatic enzymes, and they're going to digest everything. After the pancreas, we're going to talk about the liver. So liver is going to be the largest gland in the body. It has 4 lobes. It produces bile. All right, bile has a pH of 7.6 to 8.6, so it's basic. It's a little high on the pH scale. It's going to be viscous, which means it's a thick yellow to brown to green fluid. So it's yellowish, browny, green. It's what gives actual stool its coloring. All right, and vomit sometimes it's coloring. The bile salts, which are part of bile, are the only part of bile that actually helps in the digestion of lipids. So what happens is the bile salts are an emulsifying agent. All right, so emulsification is if you think about having salad dressing, right, and you have a container of salad dressing, and when you leave it by itself, the oil on the top sits on the top, and the dressing is down here. The water of all the dressing or everything else is down the bottom. Then when you shake up your salad dressing, it all becomes one, and your oil kind of becomes like little droplets within the salad dressing mixture, like that, okay? It becomes little droplets. When it becomes those little droplets, that means it emulsifies, okay? So bile salts act like an emulsifying agent, so they kind of act like you shaking up that salad dressing. Your bile salts kind of do that in your duodenum. So they're going to help you digest all of your lipids. They actually activate intestinal lipase, which is an enzyme. It ends in ASE, right? That breaks down lipids in your small intestine. After that, they also help you absorb the vitamins D, E, A, and K, DEEK. DEEK are your fat-soluble vitamins, so those hook up with the fats, and that's how you absorb them. All right, the next organ is the gallbladder. The gallbladder is located underneath the liver. It's a small pear-shaped sac, meaning it's like kind of oval, with the top of it being bigger than the bottom of it, and it's under the right side of the liver. The duct that comes out of it is the cystic duct, which we know is going to go down and combine with the hepatic duct to form that common bile duct. Then the common bile duct is going to empty out into the hepatopancreatic ampulla, into the duodenum of the small intestine. When your digestion is not occurring, your bile is going to back up into the cystic duct, and then bile is made by concentrating. Bile is concentrated, by removing water. So what we do is we actually take water out to concentrate it, which is one of the things that the gallbladder does. Lastly, an overview of digestion. And this is just general from top to bottom, what occurs, or the different processes that occur. So this is the physiology of it. So first we have ingestion, which is going to be the first one, which is taking food into your mouth. All right. And then we have mastication, which is chewing. And then we have propulsion. Propulsion is going to be when you push food down the digestive tract. This happens in two ways. The first way is deglutition, which is swallowing, and the second way is peristalsis, which is those wave-like muscle contractions that push the food down. Now, none of that is actually any type of digestion, chemical or physical. It's just moving food. After propulsion, we get to mixing. Your book calls it segmentation. This is a mixing of the digested material or the semi-digested material with all of your chemicals, and that's caused by peristalsis. Once we get the chemicals mixed in and we're mixing them all together, we get to step 5, which is digestion. So this is the breakdown of organic molecules by either chewing or crushing, which is mechanical digestion, or chemicals actually coming in and digesting it, which would be like chemicals breaking carbohydrates into monosaccharides, and that would be chemical digestion. After digestion, we have absorption. So now that we have everything broken down, we have to take it back into the body. So molecules are moved from the digestive tract to the actual bloodstream, then transported by the blood. And then we have the last step, which is excretion. So this is the undigested material that's still in the GI tract is going to be removed from the body by defecation. All right, so that was our overview, and that's our accessory organ. So we'll have one more lecture on activity, and that will be later on this week.